I want to find the limit of the square root of x plus 3 minus the square root of 3 all over x as x approaches 0. So the first thing I notice is I cannot plug in 0 for x, right? Right? Because if you do, you will be dividing by 0, and you can't do that. So what we tend to do when we see radicals is we multiply by what's called the conjugate, which is simply the radical again up top, but now the sign changes opposite to a plus, and the same thing on the bottom, because ultimately what you're doing is you're just multiplying it by 1, right? That just equals 1. And so if I multiply all of this stuff out, I'm foiling the top, so I have the limit as x goes to 0. When you multiply a square root by a square root, so I'm multiplying the square root of x plus 3 times the square root of x plus 3, I get x plus 3. It cancels the square root. You are going to see if you multiply these values, they cancel. One's plus, one's minus. So then all you're left with are these last terms being multiplied, a negative and a positive, negative. The square root of 3 times the square root of 3 is 3. And then all of this just stays on the bottom. So x plus 3 plus square root of 3. Now from here, so nicely, I can see many things cancel. So these x's cancel, those cancel. Probably should have stated to cancel 3's first to notice that there's just an x. And finally then my last step, the limit as x approaches 0, 1 is left on the top. All that's left on the bottom is this piece. I can easily plug in 0 with no problems. So this is just your direct substitution, which gives me the square root of 3 plus the square root of 3, which gives 2 square roots of 3. So it makes it easier when you multiply by the conjugate anytime you see a radical.